Dear students, welcome to my first class on Module 1, Laplace Transforms. In this lecture video, we're gonna discuss about Introduction to Laplace Transforms, definition of Laplace Transforms, some standard formulas for Laplace Transforms, and basic problems on Laplace Transforms. Introduction to Laplace Transforms. The main objective of this module is to learn new methods to solve differential equations. In particular, mainly we'll be solving the initial value problems using the Laplace transforms. So this Laplace transforms is a technique of converting the differential equations into algebraic equations, and then we'll be solving that algebraic equations by using some appropriate methods. Applications of Laplace transforms. This Laplace transforms is used to convert the complex differential equation to a simple form having polynomials. This Laplace transform is also used to convert the derivatives into multiple domain variables and then convert the polynomials back to the differential equations using inverse Laplace transforms techniques. This Laplace transform is also used in the telecommunication field to send signals to both the sides of the medium. For example, when the signals are sent through a phone, then they are first converted into time varying wave and then superimposed on the medium. Also, this Laplace transform is used for many engineering tasks such as the circuit analysis, digital signal processing, system modeling, etc. Definition of the Laplace transform. Given a function f of t is a real valued function with a condition t is greater than or equal to 0, then its Laplace transform is given by f of s is equal to Laplace transform of f of t, and it is defined like f of s is equal to Laplace transform of f of t will be equal to integral 0 to infinity e power minus st f of t dt. So this formula will be using to solve the problems in Laplace transform. Some standard functions of Laplace transform. The first one is Laplace transform of 1. It is given by 1 by s. Laplace transform of e power at. It is 1 by s minus a. Laplace transform of sine at. It is a by s square plus a square. Laplace transform of cos at. It is s by s square plus a square. Laplace transform of sine hyperbolic at. It is a by s square minus a square. Laplace transform of cos hyperbolic at. It is s by s square minus a square. Next is Laplace transform of t power n for n is equal to 1 to 3 till k. This is given by n factorial by s power n plus 1. And Laplace transform of t power p for p is greater than minus 1 will be equal to gamma of p plus 1 by s power p plus 1. So these all standard formulas will be using to solve the problems in Laplace transforms. Problems on Laplace transforms. So now in this lecture video, we'll be discussing some basic problems of Laplace transforms. First one is find the Laplace transform of f of t is equal to 1 plus 3t square minus e power 5 into e power 2t plus 2 into e power minus 10t. So now I'm going to apply the Laplace transform for this equation on both the sides, and to simplify this one I'm going to use the linearity property of Laplace transform. So first applying Laplace transform on both sides here, I got Laplace transform of 1 plus 3t square minus 5 e power 2t plus 2 e power minus 10t. So now I'm going to expand this equation by applying linearity property of Laplace transform. So we got Laplace transform of 1 plus 3 times of Laplace transform of t square minus 5 times of Laplace transform of e power 2t plus 2 times of Laplace transform of e power minus 10t. As we know that the Laplace transform of 1 is 1 by s. The constant 3 I will keep as it is. So here to find this Laplace transform of t square, I am going to use the Laplace transform of t power n formula, that is 2 factorial by s cube. Next, keeping minus 5 as it is, expanding Laplace transform of e power 2t with the help of Laplace transform of e power at formula, that is 1 by s minus 2. plus constant 2 I'll keep as it is. Laplace transform of e power minus 10t is the same formula I'm going to apply here also. That is 1 by s plus 1. Therefore, we got f of s is equal to 1 by s plus 6 by s cube minus 5 by s minus 2 plus 2 by s plus 10 is the required solution. Example number 2. Find the Laplace transform of f of t is equal to 5 power t minus 3 cos 2t plus 4 sine hyperbolic 3t. So here, to expand this each term, to expand the first term, I am going to use Laplace transform of e power at formula. To expand cos 2t, I am going to use the Laplace transform of cos at formula. To expand sine hyperbolic 3t, I am going to use Laplace transform of sine hyperbolic at formula. And also we know that the expansion of 5 power t will be e power t into log 5. So now I am going to apply Laplace transform for this equation on both the sides. So we got Laplace transform of 5 power t minus 3 cos 2t plus 4 sine hyperbolic 3t. Expanding this by using linearity property, we got Laplace transform of 5 power t minus 3 Laplace transform of cos 2t plus 4 Laplace transform of sine hyperbolic 3t. I'm going to replace 5 power t as e power t log 5. So we got the equation like Laplace transform of e power t log 5 minus 3 Laplace transform of cos 2t plus 4 times of Laplace transform of sine hyperbolic 3t. So expanding this with the help of Laplace transform of e power at formula, we got 1 by s minus log 5. So this one I'm expanding by using Laplace transform of cos at formula. So we got s by s square plus 4. This one by using Laplace transform of sine hyperbolic at formula, we got 3 by s square minus 5. Therefore, the value of f of s will be equal to 1 by s minus log 5 minus 3s by s square plus 4 plus 12 divided by s square minus 9 is the required solution. Example number 3. Find the Laplace transform of cos square hyperbolic 3t. So first we need to expand cos hyperbolic 3t. So cos hyperbolic 3t will be e power 2t plus e power minus 3t by 2. So therefore cos hyperbolic square 3t will be, by taking squaring on both the sides, we got 1 by 4 e power 60 plus 2 e power minus 60. So expanding this by using a plus b whole square formula. So now I am going to apply Laplace transform for this equation. So we got Laplace transform of cos hyperbolic square 3t will be equal to 1 by 4 Laplace transform of e power 60 plus Laplace transform of 2 plus Laplace transform of e power minus 60. The constant 1 by 4 I will be keeping as it is. Laplace transform of e power 60 is 1 by s minus 6. Laplace transform of 2 is 2 by s. Laplace transform of e power minus 60 is 1 by s plus 6. So here, so we got the answer like 1 by 4 into 1 by s minus 6 plus 2 by s plus 1 by s plus 6 is the required solution. Example number 4. Find the Laplace transform of sine square 4t. So to expand this, I am going to use this cos 2x formula. Now cos 2x formula is 1 minus 2 sine square x. So now in the place of x I am going to replace 4t. So we got sine square 4t will be equal to 1 by 2 into 1 minus cos 80. So now for this function I am going to apply the Laplace transform on both the sides. So we got Laplace transform of sine square 4t is equal to 1 by 2 into Laplace transform of 1 minus Laplace transform of cos 80. So expanding this, we got 1 by 2 into 1 by s minus s by s square plus 64 is the required solution. So in the same way, we can able to expand the formula for sine cube at also. The formula for sine cube at is 1 by 4 3 sine at minus sine 3 at, or also we can use to expand cos cube at, the formula is 1 by 4 3 into cos 80 plus cos 380. So to expand this sine cube and cos cube function, we have to use this basic formulas. Example number 5. Find the Laplace transform of sine 3t, sine 5t and sine 3t. So to expand this sine 5t and sine 3t, I am going to use sine 80 sine bt formula. So sine 80 sine bt is given by 1 by 2 cos of a minus b into t minus cos of a plus b into t. So now I am going to replace a is equal to 5t, b is equal to 3t in this expression. So we got sine 5t sine 3t will be equal to 1 by 2 into sine 2t minus cos of sine 2t minus cos of 8 t, we got it. So now I'm going to apply the Laplace transform of Laplace transform on both sides for this equation. We got Laplace transform of sine phi t sine 3t will be equal to Laplace transform of 1 by 2 cos 2t minus cos 8t. With the help of this formula we got this equation. So expanding this by using linearity property, we got 1 by 2 into Laplace transform of cos 2t minus Laplace transform of cos 8t. So now I am going to use cos 8t formula here, that is s by s square plus a square. We got 1 by 2 into s by s square plus 2 square minus s by s square plus 8 square. So therefore the answer will be 1 by 2 into s by s square plus 4 minus s by s square plus 64. So in the same way, to expand sine 80 cos pt, we have to use this formula, that is 1 by 2 sine of a plus b minus sine of a minus b. Similarly, cos 80 cos bt will be, this formula will be applying, that is 1 by 2 cos of a plus b into t plus cos of a minus b into t. Okay, in the next lecture video, we will be discussing few more problems on properties of Laplace transforms. Thank you.